Assalamualaikum dear students, hope you are fine by the grace of Almighty Allah. Welcome to NIEVS Home School. I am Sabreena Haque, Assistant Teacher of Science, National Ideal English Version School, Day Shift. Dear students, today I am going to take a science class for class 8 student based on chapter 9. Dear students, let us move forward to today's topic. Chapter 9, name of the chapter is Electric Circuits and Current Electricity. Dear students, our day-to-day life we always uses electric circuits and current electricity. Today we are going to learn about this elaborately, and we will discuss only the first part of the chapter. The flow of electric current is basically the flow of electrons. The quantity of electricity which passes a given point in a given time is known as current strength and is measured in ampere, and this is the unit of current, flow of current. For the flow of current, an electric circuit must be completed with a potential difference at the two ends of a conducting wire. The current can be direct, which is called DC, alternative, which is called AC. That means current can be two types. One is direct current, that is known as DC, another is alternative current, which is known as AC. An electrical instrument may be connected in series or in parallel in the circuits. To measure the current in the circuit, we can use an ammeter which is connected in series, and to measure voltage between 2 points we can use voltmeter, and which is connected in parallel. That means always ammeter connected in series and voltmeter connected in parallel. Dear students, these things is too much important for you, and you have to remember all the times this thing. An ammeter is used for measure the current in the circuit, and voltmeter is used to measure the voltage between two ends. Now come to lesson 1, that is flow of current. When two ends of a voltage source is connected by a conductor wire, there is a flow of current in the circuit. And we know from the modern electron theory metal that there is a very loosely bound electron in the metal which becomes free at ordinary temperature. These electrons can be moved freely within the metals. Dear students, when it is a metal piece, that time metals are joined with each other by metallic bond, and because we know the most of the metals has in their outermost orbit 1, 2 or 3 electrons, and that last orbit stays some far from the nucleus. That's why the attraction between nucleus and electrons of the last orbit is lesser than the closer orbits. That's why when the metals stay in the metallic bond, that time the last orbits electrons move freely in that metal piece, and we always know that metal piece are known with the sea of electrons, and that free electrons are responsible for the flow of current. That means that's so for the free electrons, metal is a good conductor of electricity and also heat. That free electrons carry the electricity and also the heat. When such a metal wire connected between 2 points having a potential difference, dear students, what is potential difference? That difference between two ends, the voltage difference between two ends of the conductor is known as potential difference. Then electrons which have negative charge flow from the low voltage region to the high voltage region. Dear student, you always remember that always electron will flow from the low voltage region to the high voltage region, because electrons are negatively charged, and low voltage region act like a negative end and high voltage region act like a positive end. That's why always electrons moves from the low voltage region to the high voltage region. The current will flow as long as there is a voltage difference between 2 points. If there is no voltage difference, there will be no electricity flow. Thus, if we can maintain the voltage difference, the current will continue to flow, and it is to be noted that the electrons move slowly at about 0.1 millimeter per second, while the electric signal travel at virtually the speed of the light. And how can we explain it? Think about what is happened when you turn on a tap of water. How long it will before the water from the tank at great height comes out to your tap. In fact, it comes out almost immediately, and the water which comes out of the tap is the water which was already in the pipe, and this is only an analogy. And although electric current is due to the flow of negatively charged electrons due to the old belief that current is flow positively charged, and we still maintain the old idea by conversation, but now we are known that electric current mainly is the flow of electrons, and electrons are negatively charged. Now come to the unit of current. The unit of current is ampere and denoted by A, capital A, which is flow of the coulomb of charge per second through a conductor at a given rate, and that is the definition of ampere. Now come to the potential differences. The amount of electrical power. Dear students, you have to memorize this part also, and the amount of electrical wear that has to be done to carry 1 unit of charge from one point to another in an electric field is defined as the potential difference between 2 points. Dear student, that is the definition of potential differences. If there is no potential difference to end of a resistor, no current will flow and no work will be done. Now come to the lesson 2 and 3, define types of current flow, and there are only 2 kinds of current flow. Already when we discussed the chapter first part, that time we already learned about this, that is unidirectional current and alternative current. Unidirectional current or direct current change in magnitude, but it does not change direction, is called varying current. Now come to first one, non-periodic or unidirectional current. It is also known as direct current. That's why we are saying that DC. If there is no charge in the direction of the flow of current with time, it is called unidirectional or direct current. We get unidirectional current from an electric cell or battery, and look, this is the picture of unidirectional current flow. That will a straight line, there will be no change in the direction. Also we can get unidirectional current from DC generator. Now come to the alternative current. When the flow of current changes its direction periodically, it is called alternative current. And alternative current can change its direction in a second 50 times to 60 times. And at present, alternative current AC is A or AC for A is for alternative, C is for current, is used all over the world. The reason is that the conventional production of electric power is using generators. Look, this is the picture of alternative current, and it's changing its direction with the period of time. AC is economic and easier to produce and distribute. However, the recent development of solar cell to produce electricity may change this situation in the future. Power generators in our country are being used to produce alternative current. The frequency of AC is different in different countries. In Bangladesh, the frequency is 50 cycles per second, and United States it is 60 cycles per second. Now come to the resistance. The electric current is produced by the flow of electrons when there is a difference in the potential between 2 points of a conductor. The free electrons are subjected to an electric force, and electrons move from low potential to the high potential. But during this journey, the electrons comes into collision with the ions in the metallic conductor, result the flow of charge. Now The property of creating obstacle to flow of current is called resistance. That means when it make obstacle in the flow of current, that is known as resistance. Now come to the Ohm's law. The flow of current through a conductor is determined by the difference in the voltage between its two ends. The magnitude of the current also depends on the dimension and the composition of the conductor and also its temperature. At a definite temperature, the current flowing through a conductor depends only on the potential difference between its two ends. Again, the current you get for a particular voltage depends on a property of the conductor called resistance, and the relation between voltage and the current for a conductor of definite composition shaped by George Simon Ohm, and this is known as Ohm's law, and we will going to learn about this Ohm's law. And this is the Ohm's law. At a fixed temperature, the current flowing through the particular wire or conductor is proportional to the voltage difference between two ends of the conductor. Dear student, the condition of Ohm's law is at a fixed temperature and through a particular wire or conductor. And what Ohm said, George Simon Ohm said in his law, that the current flowing is proportional to the voltage difference between the two ends of conductor. And here the current flowing is indicated as I, and voltage voltage difference is showing by V, and according to the Ohm's law, I is proportional to V. Here I always depends on V, that means V is independent expression, that's why we have to write the V in the right side, and this is shows that I always depends on V. If we increase the V, that means if we increase the voltage difference between two ends of the conductor, that time I also increase, we will get more current flowing. Now in fact, the resistance of a conductor is equal to the potential difference divided by the current in ampere, and from the Ohm's law we can see if voltage differences between two ends of a conductor is high, current flowing of the conductor will be large, and if the voltage is low, current will be low. Look, this in this graph, this line, horizontal line is shows the volt, and that means V, and the vertical line is shows the electric current or current flow, that is I. And when with the duration of time, if we divide it with the units, that time we will easily understand. With this, when the value of V is less, that time value of I also less. When the value of V is increased, that time I also increase. Like this way we can easily find out the relation of V and I. Then we can write here Ohm's law is I equal to V by R. Here R is I is equal to current flow, V is equal to volt, and what is the R? R is equal to resistance, and R is known as Ohm. The unit of R is known as Ohm, and Ohm is expressed with this sign. Ohm is expressed with this sign, and this equation is too much important for you because you will get mathematical problems by using this equation, where I is current, V is equal to voltage, and R is the resistance of the conductor. Thus, in a particular conductor, the current flowing through it is inversely proportional to the resistance of the conductor. Now come to the unit of resistance. The unit of resistance in SI unit is Ohm, that I have shown here, that is Ohm. Then if the voltage difference between two ends of a conductor is 1 volt and the current flowing through it is 1 ampere, the resistance of the conductor will be 1 ohm. This is the definition of ohm. What is the definition? If the voltage difference between two ends of a conductor is 1 volt and the current flowing through it is only 1 ampere, the resistance of the conductor will be 1 ohm. That is the definition of ohm, and this is the sign of the ohm. And dear students, this was your first part of the chapter, and this is your homework number 20. You have to make 10 MCQ from this part of the chapter, and you have to submit on Saturday from 9 am to 3 pm. Dear students, this chapter is new to you and you will get so many new words in this chapter. So read again and again. That time you will find this is so easier because we use in our everyday life electric circuit and current electricity. So you have to know these things clearly. Thank you. Allah Hafiz.